There we go. Okay, Alex.
Okay. I just want to make sure I'm pronouncing your name right. It's Naeem Altaf.
Yes, that's correct. Thank you.
Okay. Naeem Altaf leads the IBM Space Tech Innovation Group, focused on innovating from edge computing in space to the autonomous cognitive framework for CubeSat swarms to growing challenges of space debris and collision avoidance, to geospatial analysis with satellite imagery, to exploring quantum computing for opening new realms of possibilities for the new space age. Naeem's team also partners with various space agencies, universities, and space tech companies to design and build a first-of-a-kind proof of concepts and technical prototypes. Naeem is often a technical spokesperson internally and externally for IBM across a variety of topics, including cloud, Internet of Things, edge computing, and space tech. Naeem also has several articles and patents issued. He has been with IBM for more than 20 years. Take it away, Naeem.
Thank you so much, Alex. Hi, everyone. So it's an honor to be here on this with this group over here. So I'm also like you. I'm a newbie in this, looking at the planets and stuff. And then I'll go to my local. I'm from Austin, Texas, so we have quite a bit of dark skies over here. So sometimes I go to the star party, and it's amazing the kind of telescopes people bring here. And I have never even seen or heard of those where you could put a ladder and go up all the way to the tops, and it's just it's amazing stuff. So I'm really happy with the stuff you guys do and teach the younger generation. So thank you so much. Okay, let me share my. I don't see the option to share. Can you give me the permission, please, to share my screen?
Yeah. Give us 1 second.
No problem.
Right now.
Yes, I see it now. Thank you. Okay, let's share that. Okay, hopefully you can see the slides.
Good.
Okay. All right, cool. So again, thank you so much for this the opportunity. So at IBM, I think you've already explained everything. So let's move on to the next stuff. So okay, let's see the next slide. Okay, so my background is computer science here from UT Austin, and but I was always intrigued by space, and so this is how I operated at work. I started all this stuff 2 years ago in IBM, created IBM Space group and started working on it. But most of the career has been working as a computer scientist and cloud stuff and IoT and distributed computing, stuff like that. So okay, so what's our vision? So the vision for IBM Space, first of all, it's not new to us. I mean, if you guys probably remember all the work done for the Apollo missions, and how IBM was involved and all the things they did at that time. But now with all this, I think maybe US space program took a break after the the space shuttle stopped that whole program, and when SpaceX came, and I think it changed the game, right? Before we used to have maybe like in the 90s or maybe one or two or maybe two launches a year, and now you see almost every other week SpaceX does a launch, come back, goes back up. It's just like a bus going from point A to point B, and how they update. So we wanted to focus on innovation. We want to look at how the new ways of computation, what we have learned from the terrestrial work, especially in the era of cloud computing, what we have done, how can we apply some of that knowledge into the space? Because this domain of computation is increasing, as we call it, hybrid computing. So it's extending all the way from developers sitting in their home with the laptops onto the on-prem and data centers and the edges. There are different kinds of edges: industrial 4.0, smart cars. These all are different kinds of edges for different industries. And then the edge is extending into the low Earth orbit, which you also hear a lot about, LEO space economy. A lot of stuff is happening. We'll talk about that. So stuff like that, right? And extending to the lunar economy and lunar missions with this Artemis. By the way, I got the pass to go and look at the SLS launch 2 weeks ago. So I'm in Austin. So I got the pass on Thursday night, and the launch was, I think, scheduled for Saturday afternoon. So I told my kids, and my family, we're going tomorrow. We're going to drive. So we took the kids out of school around midday, and I drove 18 hours straight. The check-in was 7 o'clock. So I reached there at 6:30 by driving. And the most amazing thing which happened on the way was when I was driving on I-10 through Louisiana, and that 25-mile bridge over the swamp. That was the scariest part, because there was an accident. So we got stuck there for more than an hour. And I just happened to look down to see what's out there, and you see these big alligators. And I was like, what? And if you guys have gone through that bridge, it never ends, and there is no way out. If you're on that bridge, you're just stuck if something goes wrong, right? So anyways, we reached there, and then the bus took us to the closest point possible. And it was really cool to see that, gigantic rocket. And after 3 hours, they scrubbed it. And I asked my family, you can eat something because it's time to go back home. So I put the kids' family back in, and I drove back home all the way. So in 2.5 days, I drove 2,400 miles, and I don't plan to do it again. No. I actually got email yesterday from NASA saying, "Oh, we have a pass for you again if you want to come on September 27th." I said, "No, thank you. I'm not going." But it was at least cool to see. It's a beautiful sight. So, all right. So again, IBM, plenty of stuff we have done besides the Apollo missions. If we look at Project Mercury and then the space shuttle era, the supercomputing, Hubble telescope, IBM has been involved with NASA and ESA, the European Space Agency, in some form or fashion. I have noticed that there are many projects which we do which never even get published outside. Like, we are doing all these things, maybe for whatever reason, but we have been involved with these space agencies for a very long time. And the cool thing is, which I learned, like that 4,000 IBMers were assigned to work on the Apollo mission. So like IBM and NASA were working hand to hand, right, to work on this, to put men on the moon. So I think that must be a huge accomplishment at that time, and for the whole nation to see this happening, and it must be amazing. So, okay, so why space? It's a good question, right? Because all the things which we are observing on the planet right now, with all the things happening and the climate stuff, and by the way, I'm originally from Pakistan, and we just got hit by the floods, monsoon, and we have a population of 220 million, the fifth most populous country in the world, and almost 2/3, or not 2/3, 1/3 to half of the country is underwater right now. And we have not, this is all because we have the world's biggest mountains, the Himalayas and Karakoram. And if you see those videos on YouTube or on Twitter, the speed, the velocity of those rivers coming from these mountains, it will scare you. Just look at their speed, and it's like, whatever comes in front of them, it's just gonna take it away. It's gonna take, and it just flooded the whole country. So this thing is real. So the question comes, okay, we have all this stuff, we have so much other issues in the world. Why should we spend all this billions and trillions on space, right? Space, but I think besides, for other reasons, the space, I think it's an inspiration. It inspires us. You guys run these astronomy, clubs here, and I'm sure every now and then when you're looking deep into the sky, you are just amazed by what you see, right? And so many questions comes in mind. What's out there? There's so many typical questions. Is there life there, and who built all this stuff, and all these things. So, and from our point, it's highly encouraged, and from the chronic point of view also, that go and discover the skies, because there's so many hidden signs over there for us to go and explore. So it's highly encouraged. And then it's a daily part of our life now. So when you wake up in the morning and most of us, like, we pick up our phone first and see, if I miss something really important, because like if I'm gonna have any impact on those things. But you're checking your weather, you're checking your the traffic patterns, everything. So these all things are connected to directly and indirectly through satellites, right? So you're getting all this information, and it has an impact on your life. Then the biggest use case for, and that's where you hear this word called the low Earth orbit space economy. This new, term, this word is coined, term is coined. Basically, the biggest use case which I have seen is Earth observation. So an Earth observation can be taken into many different ways, right? Earth observation for the good of things, like where you're watching for weather patterns, climate patterns, traffic, ocean, marine traffic, all other things, droughts and melting of glaciers. Then there is, if you go a little bit above in the middle Earth orbit, you are actually for surveillance, right, and GPS systems. So there's a variety of these satellites who are constantly scanning the globe and watching, and there are so many different techniques of scanning of taking imaging now, right? So this new, probably relatively new, this SAR, right, synthetic aperture radar, if you're familiar with that. This technology, it can scan the globe regardless of day or night, or it's raining or cloudy. It can just scan the whole globe. You have optical, where it of course it has to be in the daytime. Then you have other forms of, if there are clouds covered, you can't go and take a look at that area. So this is the biggest use case. And if you take this use case and fuse this with different industry verticals, now it becomes very, very interesting, right? To see, what's happening with the marine traffic, and things are maybe piling up at certain ports because you're watching from the top, and how it impacts the economy. I'll give you an example later. That in 2020, when COVID started, how the markets crashed, how some of the firms were able to predict that from just looking at from satellite information. Disaster response is a very key one, where when you have these major earthquakes, and the first thing is your communications are gone. So the first responders who get there, now what they do, how can they get to the most affected areas, right? And this is where I think you probably are seeing a lot more about these providing internet connectivity from the LEO, where Starlink is leading, right, from SpaceX. Because basically it's just like your home dish. You go and put a dish somewhere, and you have a broadband connectivity, and then you can take care of things. Communications, common, mobile and GPS is a very common thing. ISS, it's like I call it like it's a lab. It's a lab orbiting in the orbit, and it will be end of life, I think 2030, right? So there are 3 more going up: Sierra Space, NanoRax, and Axiom. So these 3 companies, private companies, got the contracts to put the next generation of these space stations up there. So that's very interesting. Then the huge economic impact, if you look at just in the last, I guess, 30, 50 or 50 plus years of what NASA has done, and what ESA has done in their respective continents. National security, of course, and then there is so much innovation which happens in the microgravity on the on space station, and other things happening from think about all the way we have to program, because you don't have the luxury of having a very all those compute and storage and network available in space. You have very limited footprint. So how do you program to that footprint? And autonomous functions. And one of the things which you all know, right, when the rovers go to the Mars and how they land in those last few minutes, I mean, that's all basically edge computing, autonomous computing happening at that time, with computer making all those decisions. So that's a lot of innovation which we can learn from. Okay, global space economy. So by all these typical big financial firms, like whether it's Goldman Sachs, Morgan Stanley, Bank of America, I mean, the industry is listed as almost $1 trillion industry in the next 2 decades. So there's a huge, there's a lot of optimism here that we can do amazing things. On top of that, you're seeing Artemis program, and then we had like 3 nations sent 2 years ago to Mars, right? 2 probes, 1 rover, Chinese, UAE, and then the US and NASA and ESA sending missions to Mars. You have also heard the ISS is opening up to the commercial private partnership, right? Where NanoRacks is one of the companies which have actually a module attached to space station, where they act like a sort of like a third party, I guess, contractor on space station, where they can basically the space station, I think, has leased that space to them. They build their own modules, and then they can do several experiments at a much faster rate than what folks can do on ISS. Then even today, I just read on Space News that NASA is giving a second RFP to put a lander, or I think lander or rover for Artemis program. So they're opening up and asking the private sector to come forward. There already a movie shot on ISS, commercial movie, and then there's I think few more. And the ISS is also open for hotel if you have few millions laying around, so you can go and have a nice vacation there. Then space tourism is huge. We saw these flights by SpaceX, and then we see barely touching the Kármán line from SpaceX, right? From Blue Origin. It hardly reaches space, but it does not. So there's multiple companies, and then there is Virgin Galactic. They're also trying all these interesting things. So there is a space tourism, SpaceX, and so that aspect is also, but it's still very expensive. So it's going to take some time until it's affordable. Then there are many commercial launchers now. The biggest one, of course, is SpaceX now, and then you have these Rocket Labs and Blue Origin and Virgin Galactic, Firefly, and then you have traditional ones, right? The ULA and others. So this market has also opened up. That the cost of launch in the era of space shuttle was around, I think, 20,000 per pound. Now it's $1,000 per pound. And when the Starship goes up, it will be in few hundreds. So I don't know if you guys have seen, do you follow Starship, which is being built here in South Texas, Boca Chica?
Yes.
I mean, if you have seen the size of that rocket, right, it's just mind-boggling just to see that thing. So it's a 7-hour drive from here, but I think I can do it now after what I did with Florida. I really want, but I want to go when they stack up. And the funny thing is, they'll stack up, and after a few hours they take the Starship off, right? So I don't want to drive 7 hours, and by the time I reach there, they already took the ship off. Right? So I want to go. So I will probably go when they're about to do a test flight, which they are saying, right, in maybe in few months. So, but I have seen the pictures, and I always see the live video feed. It's just amazing, and the number of engines it has and all that stuff. So, okay, the other big thing is the mega constellations like Starlink, Telesat. So to date, the world has launched around 9,000 satellites, out of which 5,000 of them which are active. And you hear a lot about this challenges with space debris and all that amazing stuff, right? Now look at these numbers. This is just for next few years. All these companies want to launch these satellites in the low Earth orbit. I mean, we will be hitting like 30,000 just in this decade. Yeah. So if you think the problem is right now with those 5,000 up there and debris, imagine when these things go up. And if I'm sure when you're stargazing, you probably have seen that streaks of Starlink passing by. It's like reindeers, right? Going for like 2-3 minutes. So, and that's causing a lot of challenges for all those billion-dollar radio telescopes on the ground, because it probably creates a lot of noise in their data when they're doing deep space observation. So we'll talk about that, but let's see. Yeah. But the other thing is like I knew it's going to happen, because it's like the airline industry. If you have traveled in before COVID or in recent times, the speed used to be like dial-up speed. But imagine now when Starlink connectivity will be with the planes, right, and with the marine traffic, with the cruises, it's a $20 billion industry per year, $20 billion. So, and huge industry just for providing internet connectivity. And imagine all the areas which are remote. And again, you go into dark areas, as soon as you leave your metropolitan area, the connection speed drops very quickly. So if now you're in remote areas doing research in remote part of the world, you have a Starlink dish, you are easily hitting between 60 to 100 meg. That's a game changer for those industries. And so it's a huge thing. But there are lots of other side effects of this, which is it's going to clutter our beautiful night sky, whatever is left now. So, okay. So just to give you a bit of a landscape here. So I'm a computer scientist. I'm not a aerospace guy or nothing, but I had an interest in this. So I was like, okay, I'm not a rocket scientist. How can I be part of this amazing, cool industry? So if you look at this, right, there are all these different areas. You have your typical manufacturers, whether it's for building the rockets or, satellites. That's a specialized field. Big companies over there. And the companies who do launch and build these ground stations and radio antennas, all that stuff. But then the era we live in, this is a software-defined era, right? So all of these things are creating, like there's an enormous amount of data being produced, and that data needs to be analyzed and do something with that data in conjunction with other data. And that's where you see satellite data analytics on the right side over here. That's a huge field for all the data scientists and people who are interested in geospatial analysis. Huge field. This morning I did a 2-hour briefing with KSAT. So KSAT is the world's biggest ground station provider. And this is what is interesting to me. And again, I'm a newbie here. I don't know much. But I never understood. So all these telco companies, right? So they built the infrastructure, or basically the plumbing for the whole, let's say, US, right? The companies came right over their plumbing and made billions of dollars. Why didn't they tap into that? Maybe, right, they didn't have enough software developers, all that stuff. So now with these ground station companies, same way, they are saying, we are the ones who route all this data, this data from the space to all these companies, and they are the ones, because in software there's plenty of margins over there. So they are making all these applications and stuff on top of it, and becoming making a lot of money. Why can't they do that? I mean, if they cut the code, all the software companies can't do anything. They're relying on these gateways to get them the feed, so they can do some amazing things with it. So anyways, this is so they are so there's a lot of opportunities. They want to do what analysis we can do, and can we do at the edge. So basically, you have a bird or satellite in the orbit, right? Then you have these ground stations. Data comes downlink from there. It gets transformed, then it gets shipped to a data center. From data center, sometimes it goes to maybe a cloud provider where customer is sitting, or it can go directly to a cloud provider. So why can't we do some filtering or computation right there when it hits the ground station? So the goal of edge computing is multifold, right? First is, don't move these terabytes of information from point A to point B. If you're only, right, it's all this raw data. Can you do some filtering, extraction? Can you apply some machine learning models and extract the actionable data from that and just forward me that? I don't need to know all that data. Or you can move that data when it's cheaper, and we can archive that somewhere at a cheaper storage, something like that, right? But give me quick access to that data, because I need that data, right? And especially when you have these natural disasters, stuff like that happening. So anyways, IoT, another big area, this whole industrial 4.0, right? Basically the next generation of smarter planet, where your 5G networks are coming in, providing you a much higher bandwidth and in a given location, right? And that's what industrial 4.0 is, that you have a big factory, you have 5G networks inside, and all your different instrumentations or interconnected devices are talking over this network, and decisions are being made at these edges, and stuff is happening. And then you are pushing this data in conjunction with satellites to wherever you want it to be. And I'll talk about some use cases there also. And please tell me if I have to stop because I think 7:25. Just tell me. I can talk for some hour. Okay, so let's take a look. What are the core areas? So the core areas which you want to focus from our point of view is first is this hybrid platforms. What I mentioned was like, for example, you're a developer, you are building application, it goes to your data center, wherever your company has a data center. Your company might have also extended that data center into a cloud, so you have access to cloud also to deploy your application. Then you have an edge. Let's say in case of the space, the edge is at where the ground station is. And then from there, your edge is in the space, where at satellites and spacecraft. When you're building these applications, I want my underlying platform to be the same. I don't have to worry about there's a different architecture on space, a miniature hardware version, a miniature, maybe a little bit bigger on the edge side, a different in cloud, a different on-prem, and then I have a MacBook sitting on my, how can I build code where I write once and deploy? And that's where, you well aware of the concept of containers and how we can use the underlying Kubernetes platforms to run this. So that's the idea. Second thing is data AI. That's just a given. Plenty of sensors, tremendous amount of data is being produced. And when data is there, you have to apply some form of AI, whether it's machine learning, deep learning, to extract information. Then the quantum computing comes. That's a little bit far away. I would say at least a decade away. But this is the time. So if you have children who are getting into high school and they love programming, I highly recommend get them into the quantum. And IBM Quantum is free. Just go register yourself. You will get access to a simulator and like a 2 or 3 qubit real quantum computer. And because it's a different way of thinking, it's a totally different way of, it's not ones and zeros, it's 1, 0 and everything in between. So there's a different way of thinking, doing computation. So I highly recommend to the young generation, kids, go and learn quantum, because 10 years from now, this thing will be here. Then we partner with many different universities and agencies to do some cool stuff. Okay, use cases. The first use case is we did edge computing on International Space Station. So there are, as you can imagine, there are many experiments which runs on space station, and I was interested in the one where there's a lot of data being produced, and how can we avoid moving information and get to the results much quicker then. So in this case, the PI, the principal investigator, when they ask to take a sample from the surface because they're looking for microbes, and then run through a system, by the time they get the results back, it's almost 6 to 8 weeks have gone by, because of that it's a half a terabyte of data which has to come down, and then it has to move around, all that stuff, and then get into the hands of and process into the hands of the PI. We took the code, containerized it, open source code, and we got access to computers on ISS. We ran the code, got the raw data, and the whole process took 8 hours to run through all these different things. And in a day, we have results to the PI instead of 6 to 8 weeks. So that's one example of edge computing in space. Space situational awareness. This is the I mentioned the space debris. I will highly recommend you guys to just go on Google and type Leo Labs visualization. You will see in near real time this picture which I'm showing you, actual visualization of this globe. And this is all debris. And this is not even debris which is like 10 centimeters. This is like parts of rockets which are just left over there, and they're in the orbit. So imagine, like I said, when you have these 25,000 satellites there, and anything, the countries, the nations, and the policy makers, they have to pay special attention to this, because this is a serious problem. And like humans, right, and all of us, we don't do anything until something happens, right? So, but this is a serious threat, serious problem. Then the other piece is just a funny story. Actually, it's not funny, but it's true. So since there are so many satellites there are so many spy satellites, and you probably heard, recently, I think 2 days ago, a nation said that these satellites are target. We can just take out whoever we like. So there is a new, thing emerging in space now. Anyway, so there were these spy satellites. So there are spy satellites also. So it's so funny. So there are these satellites which are doing, surveillance, whatever. So there was one nation A satellite going, and nation B satellite was behind it, following it, making sure what it's doing, like a spy. And then the operations team noticed that behind them, the satellite who is following them, from one, it became two. Then after like a month or two, from two, it became three. So they're like, what is going on? So basically these satellites, you know how those dolls are, which you open up and there's another one inside, another one. So they were embedded. They were satellites embedded. And you can just Google this. I'm not making this up. Google it and you will read the whole article and it will tell you which nations were involved, all that stuff. Like, I mean, oh, I think we need to move to a different planet or different galaxy. These humans are crazy. So they are doing all this, think about all this, how they're making all this stuff. Okay, so this is a huge area of interest from now from national security point of view, as well as keeping the environment safe. There's a lot of companies are coming up. How are we going to clean it? And I don't know how they will do it. So, but then there are companies now. They are saying they want to advertise from the low Earth orbit. They want, I mean, I guess you guys will be really mad. Imagine you're looking at your beautiful Saturn and Jupiter, and there's an ad coming in between. The satellite is going and showing you ads in the middle. I don't want to see that. Okay. All right. Now the Earth observation, like I mentioned, it's applicable to any industry you can think of, because it's like watching from the top, right? And now these latest companies like Planet and Maxar, who are the leaders in Earth observation, they can give you a full picture within a 1.5 day. So your image is only like 1.5 day old, and they want to do the whole scan in 1 day now. So, right. So again, whether you're watching, let's say we're watching the health of planet, amazing stuff is happening. So here's an example. So in 2020, when that big crash happened in stock market, so these hedge fund managers, all these companies who have access to this kind of data, they started to see that the container ships, who are coming from, you can see the marine traffic on the web, right? So they saw that these ships are lining up at the port in New York and in California, and they could not get it off quickly, and they knew that something is blocking here. It's going to cause a market crash, and after a week, it did cause a market crash because of then the COVID was announced and all that stuff, and we had huge issues on the port. So that's just one example. Another cool example is you have these crude oil with these big tanks, right? I just learned this myself as well. So their roof is a floating roof. So basically, depending upon how much oil you have, that's where the roof is. So for example, in case of commodity wars or something is happening, right? And somebody says, oh, I have 10 tanks full of crude oil. So you can say, okay, hold on, wait a minute. Take the satellite in the daytime, and the wall of that the tank and the roof, it's going to create an angle. It's going to create a shadow from here. And the satellites can look at that, and they can calculate the angle, and they can tell you how much crude oil you have. This is, right now, if you remember that movie Enemy of the State, I think, which came from like 20 years ago, where they can see the coin on the street. Literally, they can, these new sort of satellites go to Planets and Maxar, look at the website, the pictures they publish, and imagine that's the pictures which are for public. What is classified? They can see everything. So, and you can do so many amazing things from this stuff. All right, I think I covered this edge computing at ground stations. Basically, the idea here is, can I do computation as soon as it hits the ground station instead of going all the way to the cloud? 5G, this is the industrial 4.0 stuff, and you have smarter cities, smarter hospitals, whatever the aspect of city is. These satellites will act as a backhaul. Today, we have the terrestrial networks by these major telcos who takes, or ISP providers who move your information, right? But in future, you will have these satellites which are 5G enabled, where they will communicate. And examples are like precision agriculture. So LoRaWAN gateway protocols, right? So you can go and put sensors in the field to check for the moisture or whatever, or the health of the crop. And then you have a gateway there which communicates directly to satellite. So you can be sitting somewhere in the world and you have your sensors in your fields and the data is coming to wherever your data center is. So that's another way of how satellites IoT sensors going to work. The other thing which I recently learned, so there are major accidents which happens in the mining industry. And now most of the major mining industry is basically fully autonomous. It's like there is no people in those big, gigantic Caterpillar trucks. So, and you know where they are remote controlled from in Brazil? From China. So in China, the people are sitting on these gaming chairs with these big screens, and they are driving those trucks all the way from there with the mining trucks in Brazil. So, I mean, you know, the world is changing, and, you know, when this whole concept of metaverse and other things will come, just imagine the possibilities. So, okay, digital assistant, this is basically the operations you have. How can you augment the operator? Because when the operator, we have talked to many operators, when they are operating these satellites, there's tremendous amount of telemetry data which is coming down, and they don't have time to look through all this stuff. Of course, we can use machine learning models to detect anomalies, but then you can also have these concepts of like these intelligent chatbots, where if you see something and you want information, you can just type that, sort of like an intelligent Google search, and it will go into your manuals and whatever things you have, knowledge base, and extract that information for you, or it can do automatically, so you don't have to sit there and scroll through all that information. So basically, this is augmenting the operators in data centers. Now, this is a blockchain. I just wanted to show you the example. I mean, the value of blockchain, as you know, the key things was, to me, it was besides all the fancy words, it was an immutable database. That's how I saw it. So you can, and then the key aspects were the trust, transparency, provenance aspect of basically your data, right? So if you are building manufacturing these satellites, so let's imagine, in this industry, if one launch fails, you're literally bankrupt. So let's say I'm a big, I don't know, Lockheed Martin, I want to build this $500 million satellite. I have plenty of my suppliers, they have their suppliers, then there are different test teams who are testing these things. Can we automate that process in terms of digitize it? And once you digitize all aspects of the supply chain, then you can run it through blockchain. So then you know exactly nobody is tampering with the results. Actually, 3 years ago, SpaceX caught the company, one of their suppliers, who tampered with the document saying this test passed, and they caught it, right? So, you know, in this industry, one launch goes down and you are out of business. So, but blockchain is complicated. So, you know, the challenge with blockchain is that it's like, you know, we all came in the room for a meeting and all have to nod, say, yes, we agree, and then we move forward, right? So in real world, that does not happen. So the concept is really good, but implementation is challenging. All right, I think quantum computing, there's one more slide left. So quantum computing is, it's going to tackle the problems of future, right? Which we can't handle today with your supercomputers, right? So optimization problems. So there is a lot of times when there is a spacecraft trajectory optimization is happening, even for the satellites. That's where quantum will come. Decision making, where to go and drill, and this collision avoidance stuff with all the debris. So there are many examples, but it's still early, but something to think about, you know, what can we do? And if you are interested, go on IBM Quantum and you will see so many algorithms are being built for different kinds of industry. The two big industries which we are focused right now is the financial industry and the pharmaceutical. So, all right, this is just to give you an idea. The modern development is, you know, things are being built as containers, and we wanted to have a container platform which can run on Raspberry Pi. And so we work with our Red Hat company, which IBM acquired a few years ago, and we say, give us a Kubernetes platform which is small enough and lightweight to fit on a microcontroller, so we can run our code and containers. So it's open source available. And last but not least, one of the goals when I started this IBM Space was I wanted to give access. But it's a funny story. So when I started this IBM Space, and the first thing I wanted was to launch a satellite. And like this piece of cake, I have a 3D printer. I'm going to print it and call friends at NASA and say, take it, launch it for us. And when I started, reading and learning about it, because this is not my domain, but I was learning, and like, this is extremely complicated in terms of just logistics. The technology is not that complicated, but the logistics is, you have to go through so many approvals and all that stuff. And like, okay, this will never happen. But so I was like, if we are living in these developed nations and it's so challenging for us to put something in, imagine the developing nations. It will be almost impossible for them to put something in space and have access. So I was like, we're going to democratize access to space. So how can we build something, launch it, and then make it accessible to every kid on the planet? Anyone in schools, anyone should be able to access our satellite and then push their code, run their code over there. And, it will inspire them that, they are able to run their code or do anything not anything, do some stuff on the CubeSat. And we have the Raspberry Pi running, and we have the container platform, which is the OpenShift, which I just showed you before, the microshift. It's running over there. And that's our website, endurancen.space. And if you see opportunity schools, we already have 5 schools registered to work with us. And so we actually work with Endurosat. That's the small satellite development company based in Bulgaria. So I was like, you take care of the logistics of putting stuff in space. We will take care of the software side. So they built this satellite, which you see in the picture here. And via SpaceX, we launched on May 25th. And from onwards, we took control over, and we have our whole mechanism of how we push stuff code to this satellite, so we can do some experimentation. So, okay, and that's about it. So thank you so much.
Any questions?
Yeah, I should have written this down before, but how many satellites have been put up in orbit and how many are still active?
So the one which public knows of course, there's a lot of other stuff which goes on. The public knows of is around 9,000 and 9,400 something, and 5,500 roughly are right now operational. The rest are all just junk, just floating out there. Some got burned, some are still debris over there. But now SpaceX is already up to, I think, 2,400 in 2 years, because they do launch every other week. And they want to get to 12,000, and Chinese, they want to have another 15,000. They haven't even started yet. And then there are other companies. So it will be around 30,000 satellites in the next 5 years. So it's gonna be a challenge. I mean, it's gonna be a challenge.
Does the space junk contribute to global warming?
It can. Okay, that's a good question. I have to think about it. It does not help. I mean, it can help people realize that global warming is happening and look at these things which is happening to the planet. Maybe people will, because all of this observation which is happening from these amazing satellites and the imagery they're taking, hopefully it will help people to stop this stuff that they're doing on the planet.
But the junk is not causing any kind of climate change.
I mean, there are talks now that they're saying, that the carbon footprint of all these launches by SpaceX is causing so much. But it's still early data. We will probably know in a year or two. But there are people saying, oh, you talk about this one, look at what these rocket launches are doing, right? So we'll see.
I don't know if they put up CO2. I'm not sure if the byproduct is for rocket fuel.
Depends on the fuel.
Yeah, and I heard they do use different fuels.
SpaceX uses methane.
Yeah.
Yes.
Methane's one of the worst.
Yeah.
Yes.
But not if it's burned. If it's burned, it's CO2, and that's not as bad as methane. So
Right. As long as none of it gets out.
if you see the methane, burn it.
Yeah.
Burn it from space.
Still absorbed.
Further questions in the room, on the net? Anybody out in Zoom land have a question?
Yes, Shanta?
There we are.
Hi. Hi. So I have a question about like the last week we had, this is the climate week. So we had this CIFOR from Austria space for sustainability. So exactly what you were saying, they were talking about all the remote sensors. So right now, if you taking more for your perspective, for example, now we can measure the CO2 level based on the imagery. Is it, what I'm trying to understand, is it really we need sensors or for based on the imagery, for example, the weather patterns, they take the pictures and then they could predict, what's the weather it's gonna be. Not necessarily you have sensors as well, but more of the pictures the satellite takes, right?
So I mean, okay, no, thank you. So I mean, I guess it depends upon what kind of imaging sensors are there to capture that information. But there is so much other things which we can capture the patterns, like the droughts happening or the melting glaciers and other things, right? So, but then there are so many other sensors in the atmosphere to capture all these, the carbon footprints and other things. So it's just a combination of all these sensors that you fuse this data to figure it out. But the thing is, you probably have seen those 17 goals from United Nations for sustainability, right?
Correct.
And basically space, it helps on all of those 17 goals, almost all of them, if you're familiar with them, right? Because it's an additional data source to you for decision making. And it's constantly, it's like, for example, the easy analogy is if you're living in your home and you have, let's say there's no roof there and somebody's watching you, after maybe a couple of weeks, they will exactly know your pattern, like what you do, all right? So that's what these satellites are doing. They're watching you 24/7, and they exactly know these patterns now. And from there, they can, and plus it's not only that, then you have all these the solar weather patterns, which comes and hits the planet as well. So do you know what will be the cool project? And I think it's a utopia. It's just going to be very, very hard. If we create a digital twin of Earth, I think that will be amazing. We will need, let's wait till quantum computing to be ready, like in next 10, 15 years. But imagine, you have an interconnected world with all these amazing sensors and stuff, and in almost near real time, you can watch the health of a planet, and then you can optimize, right? Maybe in the movies they can show that kind of stuff, but in reality it will be really cool. I mean, we don't have to do the whole globe. We'll just start with one area and create a digital twin of it.
Sounds like the Matrix.
Yes.
That's what people want to take back.
Any further questions? Anything out? I'm not able to see the Zoom session. Any other Zoom? Well, yeah, but that's behind me.
Yeah, okay.
My neck is already cranking up. All right, if nothing else, I'll say thank you very, very much, Naeem.
You're most welcome.
Very informative.
Thank you very much. That was really cool presentation.
Most welcome.
Thanks.
Enjoy your evening. All right.
Thank you very much.
Take care. Bye-bye.
Okay, stop recording, Eric.